So 5.2.4 tells us that we have a bunch of metal plates. Each plate has a mean of 4.3 and a standard deviation of 0.12. It says, what's the distribution of two plates? Let's see, so I forgot to say, it said the widths or thicknesses are normally distributed for each plate. So if you want to look at the distribution for, say, two plates stacked on top of each other, well, first thing, if you add two random variables, it will still be normal. So we know it'll be normal. Then what we're going to say is if I add two plates, let's make up a new variable. You can make up anything you want. I'll say t for total. If I just take one plate x1 and add a second plate x2, that's how I'm going to get my total thickness. So I can find the expected value of t using the rules that we learned in section 2.6. So you need to go back and rewatch that lecture to learn these rules. But the expected value of t would just be the expected value of x1 plus x2. Well, the rules say just take the expected value of each one individually. So expected value of x1 plus the expected value of x2. Well, the expected value of x1, that's just your mean. So it's 4.3 plus 4.3 gives me 8.6. So that's your new mean. And we don't actually have a rule for standard deviation that works. You have to go to variance. So it'll be the variance of x1 plus x2. And it says take each individual variance and add them together. So variance of x1 plus variance of x2. So variance of x1, let's see, we don't know the variance, we know the standard deviation, so I'd have to do 0.12 squared to get variance, plus 0.12 squared. So this gives me 2 times 0.12 squared. Now I can find the standard deviation by taking the square root of that. So the square root of the square root of 2 times 0.12 squared gives me the square root of 2 times 0.12 is how your textbook might put it. So we know is normal. I know my new average will be 8.6. I know my new standard deviation will be the square root of 2 times 0.12. That's the distribution of it. For B, it's very similar, but instead of using all of these rules by hand, we can use the shortcut formulas. Because we use the average so often, we just memorize the shortcut formulas. So we want the average of 12 plates. So the expected value, well, first of all, we know it will still be normal, because if you have a bunch of normal things and you take the average, it will still be normal. So the expected value of x bar, or the average, will just be equal to mu, which is your population mean, which is 4.3. And the standard deviation of x bar, we've used this formula so many times that we don't have to figure it out each time. We just memorize it. Will be equal to your original standard deviation over the square root of n. So my original standard deviation is 0.12 over the square root of 12, and whatever that gives you.